Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acid-catalyzed ring expansion via carbocation rearrangement, semipinacol type or cyclobutyl carbonyl to cyclopentyl rearrangement. Moving on to the next step. Identify the starting material. The starting material is spiro 3.5, nonan 6-1, a spiro compound where a cyclobutane ring and a cyclohexane ring share one carbon, with the ketone on the cyclohexane ring adjacent to the spiro carbon. Moving on to the next step. Protonation of the ketone by conc. H2SO4 generates an oxocarbenium ion, protonated ketone, or the acid facilitates formation of a carbocation alpha to the carbonyl. And for the final step, the spirocarbon bearing the cyclobutane ring is alpha to the carbonyl. Under acidic conditions, protonation of the carbonyl oxygen creates an oxocarbenium ion. The adjacent C to C bond of the cyclobutane, a strained ring, migrates to relieve strain. This is a 1,2 alkyl shift ring expansion of cyclobutane to cyclopentane. The cyclobutane ring, 4-membered, expands by migration of one C to C bond to give a cyclopentane ring, while the cyclohexane ring, 6-membered, contracts to a cyclopentane ring. This converts spiro 3.5 nonane skeleton into a spiro 4.4 nonane skeleton. After the 1,2 shift, the positive charge is quenched by deprotonation, or the oxocarbenium collapses, giving spiro 4.4 nonan 1-1 to cyclopentane rings spirofused with a ketone on one ring. Spiro 4.4 nonan 1-1, where both rings are 5-membered and the ketone is on one of the cyclopentane rings at C1. Why other options fail? A. Shows ketone on one cyclopentane ring, but the structural drawing indicates the ketone is at a different position. C2. Inconsistent with the rearrangement product. C and D involve double bonds, which would require elimination rather than a simple 1,2 shift rearrangement. No elimination is expected here. Therefore, the correct answer is B. Therefore, the correct answer is option B.